In this unit, what we are trying to do, we generalize the mesh and nodal analysis using expression. In this case, normally what we try to do, we use only nodal. If you are talking about nodal, we only have the current source. If you are talking about mesh, we only have the voltage sources. So as we know that the what is I1 across V1 or I1 across the R1 is in R2 is this one, and R3 is I3 is this one. So what is I1 is that V1 divided by V1 minus 0 divided by R1. What is R2? V1 minus V2 divided by R2. What is I2? And for I3, V2 minus divided by minus 0 divided by R3. So this is, we have all these values. So as we know that the 1 upon R is G, so we can say that G1 V1. We also have G2 V2. So G2 into V1 minus V2, and uh, we have for R3 I3 we have G3 into V2. As you can see, 1 upon R3 is G3. So what we have to do, we try to solve the nodal analysis at this point and at this point. When we apply the nodal analysis, as we know that the current is entering from here, the current is leaving here, current is leaving here, current is leaving here. So we can say that I1 is enter plus this one is G1 V1, this one is, we have the current is moving, is called I2, and this one we have moving also G2 into V1 minus V2. So this is the equation 1, and the second part we have the this part. So we have entering is I2, and we also have this is entering, so we have V2 V1 minus V2 into G2 equal to this is leaving, also the leaving is G3 into V2. So we have these equations, and we can put this equation in a form that we have the variables V1. When we solve this equation in terms of V1 and V2, so as we know that the V1 is equals to G1 plus G2, and V2 is equals to minus G2 V2, right? And this one, the I1 and I2 are constant in this equation, as we consider the V1 and V2 are variables. This is variable, and this is also variable. When this is variable, this is a constant, so we can say I1 minus I2 is a constant. So what we do, we have this equation, G1 plus G2 is the coefficient of V1 is G1 plus G2, for coefficient of V2 is minus G2, and then the constant of this equation is I1 minus I2. Similarly, when we solve for this equation, we can see that this is this becomes G2 V1, and this is minus G2 V2. So we move this one on the right side, so this becomes minus G2 V1. This, when this move this side, so it becomes G2 plus G3 into V2. So what we basically, what is the purpose of doing this? We have tried to generalize it. It's very easy that we are trying to solve it in a way that we calculate the branches. This, how many branch is connected with this node? There are 4 branches. 1, 2, 3, 4 branches is connected with this node. So what we are trying to do, those, when we try to want to calculate this value, the value at the V1, then to calculate the V1, so we have 1. So we add all the conductance of all the conductance connected with this branch. There are only 2 conductors. We add, when we come to calculate this one, we add the conductance of this voltage 2. So means a diagonal, V1, and we have diagonal is like first node, second node, third node, fourth node is going diagonal, and diagonal is just have the conductance addition. And the non-diagonal, this means that V1 is connected to, so column, this is row 1 and column 2. So we have the negative conductance of this one, so minus G2. So if we connect if we stand from here, so this we can say that the 2 to 1 from moving second row 2 to 1. So the second row, first column. So we also have the negative conductance. So on the right, on the diagonal, we have only the addition of the conductance, and the non-diagonal we have the negative of the conductance. This is become the equation. And the current entering minus leaving is becomes the constant. There's only one current is entering, so it becomes positive only. If it's just leaving, that's right, it becomes negative. If it's leaving, currently I2 is entering in this node, so this is positive I2. So let's take an example. This is generalized. This is a generalized form. So let's take an example. We have node 1, we have node 2, we have node 3, we have node 3, and we have node 4. When we have node 3, so at node 1, how many these branches are connected? There are 3 branches. So for 3 branches, we can say that we have to G11. Understand, G11 is the, what is G11? G11 is the conductance, addition of conductance at node 1. So to calculate G11, what is the 1 over 5 plus 1 over 10? So this is 0.3. So similarly for G2 we have 1 over 5. G22 we have 1 over 5, 1 over 8, 1 over 1. So 1 over 5, 1 over 8, and 1 over 1 is become G2. This become, we are talking about a diagonal one. Now. Then we have G33. So G33, 1 over 8, 1 over 4, 1 over 8 plus equal to this one. And then we have G44. So we have this point, we have 1, 1 over 1, 1 over 8, 1 over 2. This is the value of G44. The rest of the diagonals is the, we can calculate. Can we go from 1 to 2? Yes, we can go from 1 to 2. The conductance is negative 1 upon minus 1 upon 5. Minus 1 upon 5 is minus 2. Can we go from 1 to 3? No, we cannot go. 1 to 4 cannot go, so it becomes 0, 0. So G13 and G14 is become 0 because there is no direct connection with 3 and 4. Similarly, if we stand at this point, we have 2 can go to 1, yes. So if you can 2 can go to 1, so it becomes minus 1 upon this resistance, so minus 1 upon 5. So can V2 can go to 3? Yes, can go. So this is the resistance. So the diagonal. So this is, I say that this is diagonal. So this is minus 0.2. V2 can go to 3. So the second row can go to 3. So 1 upon 8, and 1 upon 8 is minus 0.125. Can we go from V2 to 4? Yeah, we can go from V2 to 4. What is the negative? Negative of 1. So this is negative of 1. Similarly, we fill all the matrix according to that. So we have this matrix. So the next we have to calculate the constants. How many in the which is entering is positive, which is leaving is negative. So this one we have positive 3. We have positive 3. This one is leaving, this one also leaving, so minus minus to the plus, but sign will become minus, so it become minus 3. This node have no current source connected with this node, so it becomes 0. This one also entering, this one also entering, so it becomes, this node becomes 4 enter and 2 enter becomes 6. So this is the way to calculate nodal and mesh analysis inspections. So next, similarly, if we go for next example, so we can see that we have 1 node, we have 2 node, we have 3 node, we have 4 node, and we have 4 nodes. So the resistance connected to this nodes become 1 over 1, 1 over 5, and 1 over 10. So we can say G11 is equals to 1 over 10, 1 over 5, 1 over 1, which is equals to 0.1, 0.2, and 1 over 1 is 1. So this becomes 1.3. So G1 is 1.3. Similarly, if we calculate for others, let's give you example again. Then let's this one. If you can see this one, both are entering in this one. The current at V2 is because entering becomes the constant becomes 1 plus 1 plus 2 is 3. So this is the very easy way to calculate the nodal analysis using this inspection method. Very easy to solve it. Similarly, for mesh analysis, what we have to do in mesh, the resistance in a loop will be add, and the non-diagonal, like non-diagonal elements, we have the resistance comes in between the two loops, like this one minus R3. So this is minus R3, so that because it exists between the two loops in mesh. So let's take an example. This we have taken example of this one. So if we have 5 loops, as you can see here, so for first loop, if you want to calculate the first loop, the how many resistance we have? We have 2 plus 2 plus 5. Say that R11 is 5 plus 2 plus 2 is 9. So another one, we have this one, this is 2, 4, 6, 7, 8, 10. So this is the R22 is 10. Similarly, we have applied for 3, we apply for 4, we apply for 5. We just add the resistance in the loop. And non-diagonal, can 1 is connected with 2? Yes. Which is the resistance between this? Is 2. So you can say minus 2. So 1 to 2, R12 is minus 2 ohms, and R21 also minus 2 ohms. R12 is minus 2, or also R21 is minus 2. 1 can connect with 3? Yes. With is the resistance? This one. So 1 3 and minus or 3 1 is equal to minus 2 ohms. 1 is connected with 4? No, 0. 1 is connected with 5? No, 0. So this is 1, 4 and 5 as 0. 1 to 4 and 1 to 5 is 0. 5 to 1 and 5 to 4 also 0. So this is the way we calculate the resistance. So finally we have this matrix. Now we are talking about the voltages at the constants that we have. That constant we have at node current 1. Current 1, as the current 1, basically this is the supply, this is the supply, this, then we have the current is moving outward, the plus sign for the node mesh analysis and by inspection is positive. So we have positive 4 for the loop 1. This current is moving from this side but is moving out from this side, so this is 10 minus 4 is 6 for I2. For I2, 10 minus 4 is 6. For current, for third, the current is moving out from the 12 volts and moving away from 6 volts, so minus 12 plus 6 is minus 6. And then for fourth one, it has no voltage source, 0. The fifth one has moving, current is moving out from the minus is minus 6, so minus 6. So this is the matrix, and you can use it to solve. This is preferable, you use the substitution equation to convert this equation into 3 variables, and then whatever the rules you want, you can use it to solve these equations. Now we have another example for this case, that for the first for this one we have loop 1, loop 2, loop 3, loop 4, loop 5. So for the first loop we have 50 plus 40, then we have 80, so 90 plus 80 is 170. Okay, for loop 2, 40, 30, 70, 70 plus 10, 80. Loop 3, 30 plus 20, 50. Loop 4, we have 80 plus 10, 90. Loop 5, 20 plus 60 is 80. So we have this diagonals. For the non-diagonals, 1 is connected with 2, yes, using the 40s, minus 40. So minus 40 and minus 40. 1 to 2 also minus 40, 2 to 1 also minus 40. So first row, second column minus 40, second row, first column minus 40. This is called symmetrical matrix. Similarly, 1 is connected with 3, no. 1 connected with 4, yes, with 80. So we can say 1 to 4 is minus 80 and 4 to 1 is also minus 80. 1 to 4 minus 80 and 4 to 1 minus 80. Similarly, so we have this one. So now we have talking about the voltages. This one leaves out from the positive is positive 24. Then this one is leaves out from the negative, is become minus 12, because this one has no, it becomes 0, this one becomes minus 12. this one has going out from the minus, so it becomes minus 10, and this one is moving out from the minus 10, it becomes positive 10. This one comes out from the positive side, so it becomes positive 10. So this is positive 10 and this is minus 10. So I hope you understand this analysis, nodal mesh analysis.